All right, guys, so here's going to be some notes over 5-4 analyzing graphs of polynomial functions. So first of all, whenever you're working these in this table, what I'm looking for is zeros. So zeros are also known as x-intercepts. So I'm looking for where I would find zeros in the y on the table. So if I'm thinking about any type of graph, the zero value is between negative and positive numbers. So when I look at the table, I'm looking between the positive and negative numbers. And at those locations, I should have some zeros. So how am I finding where these zeros are located? They're located when I have a change in value from negative to positive, or from positive to negative. Next up, I need you to take a second to draw this graph over here that says relative minimum and relative maximum. You don't necessarily have to write all of this wording, but I'm going to tell you a couple of things about it. A relative minimum occurs when I have a low point in my graph. It's like a U shape. And then a maximum occurs when I have a high point on my graph, or like a mountaintop. You guys are familiar with minimums and maximums when it comes to quadratics, but in the case of any polynomial other than quadratic, I would just be looking for the shape of the curve. So U shape is a minimum, and then upside down U shape would be a maximum. What's also important to note is that minimum and maximum functions, there's another word that we call them, it's called extrema, and another word that we call them is called turning points. So min, max, extrema, and turning points, they can be used interchangeably. They all mean the same thing. Okay. Here's some more information about minimum and maximum points. The number of turning points, or min/maxes, that occur in a graph is at most the degree minus 1. So for example, if I had a little quadratic here, if I had x squared, notice how it only has one minimum because the degree is 2 and I subtract 1, so it only has one turning point. Conversely, the minimum degree is the number of turning points plus 1. Don't forget what degree means. It's the highest power of your polynomial. All right, this graph here, we actually did work with it a little bit in our warm-up. Our daily ticket, we talked about our roots and we talked about where they occurred. Well, now we're going to talk about the multiplicity of the roots. So depending on how my graph looks at a certain location of the root, we'll have either a multiplicity of 1, which pretty much looks like a linear graph, or a straight line, or we could have a quadratic, which looks like a U-shaped curve. Or finally, I could have a cubic, which looks like a cubic. I don't really know what else a cubic looks like. So a linear location would have a multiplicity of 1. A quadratic location would have a multiplicity of 2, and a cubic location would have a multiplicity of 3. By looking at this graph here, and draw this in your notebook and draw it really carefully and nicely. This one right here, look where it crosses the graph at -1. That's going to be a multiplicity of 3, just because that shape where it hits the root, that shape is a cubic shape. Then if I look at this one, this shape is a quadratic shape, so that would be a multiplicity of 2. And finally, this shape crossing through the axis would be just a straight line, so that would be a linear multiplicity, or multiplicity of 1. Okay, you'll need that for what we're about to do next. What we're about to do next is write the polynomial in standard form. Standard form just means literally write it in order from the highest exponent all the way down to the lowest exponent. So I'm going to give you some steps and then we're going to do it. First step is to find the roots. Find roots. So we already did that. We have x equals -1, x equals 1, and x equals 2. Sorry, it's having a hard time marking those places. Second thing we're going to do is write these as a factored form. So we're going to put them in factored form. Factored form. What I mean by factored form is make one side equal to 0. So if I were to do that, I just add 1 to both sides. I would subtract 1 on both sides, and I would subtract 2 on both sides. So in factored form, this would appear as x plus 1, x minus 1, and x minus 2. All I did to get it in factored form was move that constant so that one side was equal to 0. Finally, what I'm going to do is add these multiplicities onto the factored form. Multiplicity. When I add the multiplicity, you'll notice that I'm going to put it as the exponent. So I'm just copying it down first. And let's talk about what we discovered on the last slide. Right here, I had a multiplicity of 3. So this is going to be to the third power. Third power. Right here, I had a multiplicity of 2, quadratic style. So it's going to be to the second power. And finally here, I had a multiplicity of 1, which I technically don't need that 1 there. So here's the thing, guys. What's really nice is if this question asks, hey, write this in factored form, then we would be good. This is factored form. We would have our answer and we're done. But because it specifically states in standard form, what we need to do is actually distribute this out. Distribute. I'm going to distribute it fully. That means x plus 1 times x plus 1 times x plus 1 3 times, x minus 1 times x minus 1 2 times, and x minus 2 just that 1 time. I need to distribute that all out. Yes, it's going to take a bit of time. Is it possible? Yes. Will you like it? Probably not. But let's see how it's done. What I'm going to do first, just to make it a little bit easier to look at, is I'm going to write it in different colors. I'm going to do x plus 1 to the third in red. Then I'm going to do x minus 1 squared in green. And then I'm going to do x minus 2 in blue. So what's going to be the most challenging to distribute is this part in red. So what I'm going to do is use binomial expansion, which most of you guys call Pascal's triangle, to figure this out. Seeing how my exponent is 3, that means I need 4 rows of Pascal's triangle. 1, 2, 3, 4. This is work. I'm going to do it kind of on the side a little bit. So I'm going to pause the video while I do that. All right, so notice here what I did. If you forgot about binomial expansion, I have my coefficients, and then my x is going decreasing power, 3, 2, 1, 0, and then my 1 is going increasing power. So I'm going to write out what this would look like. It would be x to the third plus 3x squared plus 3x plus 1. Now I'm going to go ahead and expand the x minus 1 squared. I'm going to just distribute that. If you want to use binomial expansion, you can, but it really doesn't take too long to do this. And then plus 1. So in green, I'm going to have x squared minus 2x plus 1. And then I still have this blue section over here, this x minus 2. What I'm going to do next, I'm going to distribute these two. It really doesn't matter necessarily what order you distribute in, but I'm going to do all that work off to the side. I'm going to write it on the side in blue, and I'm going to pause. All right, so what I have here in blue is the answer that I got after I distributed x squared minus 2x plus 1 and x minus 2. You can see the work down here in blue. Now what I'm about to do is distribute this red and this blue. I'm going to pause in increments just so that I won't have to make 2 videos, but I'll try to explain as I go. I'm going to first distribute the x to the third. All right, this is me distributing x to the third times the blue set. Now I'm going to distribute 3x squared times the blue set. All right, so here in purple is what I got after I distributed the 3x squared. Next, I'm going to distribute the 3x times what's in blue. All right, you can see here in pink what I got for distributing the 3x. And also here in purple, I changed that exponent to a 4. Notice I'm lining them up with their powers. Lastly, I'm about to distribute the 1. So it took a lot of work, a lot of time and patience, but I did distribute everything fully. And now I'm about to just combine my like terms. I have x to the 6th minus x to the 5th. Let's see, minus 8x to the 4th. 14, 1, 2, plus 2x to the 3rd. Plus 5x squared minus x minus 2. All right, thanks guys.